Hi everyone, my name is Michael and I'm an intern with Mathleague. Today we're going to be looking at number 22 from the sprint test of set 12208. So without further ado, let's get started. The question reads, how many 5-digit positive integers have at least 3 consecutive digits that are all the same digit? And our choices are A, 2,430, B, 2,520, C, 2,349, D, 2,448, or E, other. And we can break this down into 3 cases. There can be exactly 3 consecutive identical digits, exactly 4 consecutive identical digits, or all 5 of the digits can be identical. So let's look at this case by case. For case 1, there can be exactly 3 consecutive identical digits. Now, there are 3 ways this can happen. Either the first 3, the middle 3, or the last 3 digits are identical. And we'll consider these subcases 1A, 1B, and 1C respectively. Now, let's look at subcase 1A. We know that the first 3 digits are identical, and the 4th digit has to be different from the first 3 digits. Now, for the first 3 digits, the only digit we cannot choose is 0, since that would result in the first 3 digits being 0, thereby producing a number that is no longer 5 digits. So for the first 3 numbers, we can choose any of 9 choices. And without loss of generality, let's say we choose 1. Now for the 4th digit, it cannot be the same as the first 3 digits. Otherwise, we would have 4 consecutive identical digits, which is not covered under case 1. So we have 10 minus 1 is also 9 digits we can choose for the 4th digit. And let's say that we choose 0. Now for the 5th digit, we can choose any digit we want, since even choosing a digit that is identical to the first 3 digits or the 4th digit will not create a string of more than 3 consecutive identical digits. So that gives us all 10 choices for the 5th digit. And let's say we choose 2 to give us 11,102 as a number, a 5-digit number that does have 3 consecutive identical digits. Now, this means that there are 9 choices for the first 3 digits, 9 for the 4th digit, and 10 for the last digit, which gives us a total of 810 5-digit numbers satisfying case 1A. Now we continue to subcase 1B, where the middle 3 digits are identical. And again, we know that the first digit cannot be 0, so there are 10 minus 1 or 9 ways to choose the first digit. Now, the middle 3 digits are sandwiched by the first digit and the last digit. And this means that they can be neither the first digit nor the last digit. Now, looking at this, we know that the middle 3 digits then cannot be the same as the first digit, which gives us 10 minus 1 equals 9 choices for the middle 3 digits. Now let's say, without loss of generality, that we chose 4 for our first digit and 7 for our middle 3 digits. Now, we know that the only restriction on our last digit now is that it can also not be the same as the middle 3 digits, which gives us 9 choices. And let's say we choose 6. So that gives us 10 minus 1 equals 9 for the first digit, 9 for the middle 3 digits, and 9 choices for the last digit to give us 729 numbers, satisfying subcase 1B. And finally, we have subcase 1C. So we have that the last 3 digits are identical. Now, we know that the first digit, there are 9 choices again. Let's say we choose 5 this time, since the first digit cannot be 0. The second digit can be any digit, and we'll just say that we choose 8. Now, the last 3 digits cannot be the same as the second digit, since that would create 4 consecutive identical digits in this 5-digit number, which is under case 2 instead of case 1, which would lead to double counting. So we know that the only restriction is that they can't choose the same digit as the second digit. Let's say we choose 9, and then that means that there are 9 choices for the first digit, 10 for the second, 9 for the last 3 digits, which gives us again 810 numbers that satisfy subcase 1c. Now, this gives us a total of 2,349 five-digit numbers under case 1 as a whole. Now, moving on to case 2, we have 4 consecutive identical digits. And this means that we can either have the first 4 digits be identical or the last 4 digits be identical. Now, if the first 4 digits are identical, then there are 9 choices for the first 4 digits, since the first digit cannot be 0. And let's say that we choose the digit 3 without loss of generality. And for the last digit, we just can't have the same digit as the first 4. So say we have 4 as our last digit, and that gives us 9 choices, since the only restriction is that it can't be the same as the first 4 digits. So that gives us 9 times 9 is 81 numbers under this first subcase of case 2. And for the second subcase, it's very similar. The first digit can be anything except for 0, let's say 6, and the last 4 digits simply have to be different from the first digit, giving us 10 minus 1 equals 9 choices. Let's say we choose 8. And that gives us, again, 9 times 9 is 81 numbers under the second subcase of case 2. And if we add these two numbers together, add these two subcases together, we get 81 plus 81 is a total of 162 five-digit numbers under case 2 with 4 consecutive identical digits. Now, finally, we take a look at case 3. In case 3, the simplest case, we have 5 identical digits, which means that all 5 digits are the same. And since we know that the first digit cannot equal 0, there are 9 choices for the first digit. And since all of the other digits are identical to the first digit, that means there are 9 five-digit numbers satisfying case 3. So the numbers would be 11,111 and so on, all the way until 99,999. So these 9 numbers are the only ones that set the 5-digit numbers that satisfy case 3. Now, to find the total number of 5-digit numbers that have at least 3 consecutive digits that are all the same digit, we can add the 3 cases together since they are mutually exclusive. And the reason that they're mutually exclusive is because we decided that there would be exactly 3, exactly 4, and exactly 5 digits identical in each of our cases. So we see that there were 2,349 five-digit numbers with exactly 3 consecutive identical digits, 162 with exactly 4 identical digits, and 9 five-digit numbers with all 5 digits identical. We add those together to get a total of 2,525 digit numbers, which gives us a B as our final answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.